Hi class, I'm Dr. Scott Adamson. I'd like to welcome you to our calculus course. But this particular video is going to be some prerequisite information that you will use in your calculus courses in many different places. It has to do with some trigonometry, some trigonometric identities, and even more specifically, Pythagorean identities that we're going to explore here today. So let me just remind you of some work that you've done in the past with trigonometry. First, here we have the traditional Cartesian coordinate system. There's an origin, there's a horizontal, often called the x-axis, there's a vertical, often called the y-axis. And we know from our work in the past that we can plot a point by starting at the origin, moving a horizontal distance along the x-axis. That horizontal distance is referred to as a distance x, a horizontal length. And then we stop wherever we need to stop in a particular situation, and we go straight up in the y direction, a certain distance we often call y, to create a point x comma y. Now, what I'd like you to imagine is this point ends up on a circle, and this circle happens to have a radius of 1 unit. Now, it could be 1 mile, it could be 1 foot, it could be 1 meter, but this circle is called a unit circle, just has a radius of 1 unit, whatever it is. And so we have this point x. Now, from your trigonometry, you likely know that that distance x will vary depending on the angle theta that's created here. And we have this in a previous video as well, that as theta changes, x changes, and that horizontal distance is known as the cosine of theta. And kind of similarly, as theta changes, that y distance changes, and it has a special name. Y is called the sine of theta. So as theta changes, x changes. As theta changes, y changes. Now, what I want you to focus on for this particular video is look at the nature of this. We have a right triangle. And when you have a right triangle, there's a very famous theorem. You've probably heard of it. It's called the Pythagorean Theorem, named after the Greek mathematician Pythagoras. And the Pythagorean Theorem says this: x squared, this leg of the right triangle squared, plus y squared, that vertical leg squared, is equal to the hypotenuse squared. 1 squared is 1. Now, if we substitute x and y with their trigonometric correspondences here, x is the cosine of theta. So we would say cosine of theta squared plus sine of theta squared is also equal to 1. And this identity is very useful. It'll come up a lot in different things you do in math and physics. Hey, notationally, I just want to highlight something. While it's true to say cosine of theta, that length squared plus that length, sine of theta, squared is equal to 1 squared. The notation for this in print is often like this. We say cosine squared of theta, and then we say sine squared of theta. But even though we put the squared there for convenience, we know it means the cosine of theta, that length squared, and the sine of theta, that length squared. Now, what's going to be useful to us is different manipulations of this. For example, you might just do some algebraic things here, like the cosine squared of theta is equal to 1 minus sine squared of theta. Notice if you just subtract sine squared from both sides, we get another identity that might be useful to us. So here's a couple of identities that we would maybe use in some future mathematics. Now there's one more that I'd like you to see. So cosine squared plus sine squared is equal to 1. We could also, now you just have to kind of trust me here that there's a reason for this, but we could algebraically divide every term by cosine squared. Can you imagine? Take cosine squared of theta and divide by cosine squared of theta. Take sine squared of theta and divide by cosine squared of theta, and take 1 and divide by cosine squared of theta. Now, if we just simplify this, what we have is cosine squared of theta, that length squared, divided by that length squared would be 1. Sine over cosine, that ratio sine over cosine is equivalent to tangent. So this could be written as tangent squared of theta. And then 1 over cosine, the reciprocal of cosine has a name. It's called secant squared of theta. And so another identity that you might find useful in future mathematics and physics and other sciences is this Pythagorean identity as well. So these three you're going to see in the near future. Thanks for joining us. Continue clicking on the videos to see where this will be used, and please click on the EdVantage logo and subscribe. I'll see you in the next video.